Okay, moving on with rationals, we are taking a look at now adding and subtracting them, or in a word, combining. So before we get too far along, let's go ahead and remember what if we just had numbers. So I have set up here a simple question. Our first order of business would be to get a common denominator. So let's write it down. Our first order of business, common denominator. All right, so what is our common denominator? Now, a shortcut is generally to take 4 and then times 6, and you get 24. Multiply your denominators, but that's not the least common denominator, and that will give us some extra work at the end. Our least common denominator is 12. Let's think about why. So the 4 could be prime factorized into 2 times 2, and the 6 could be prime factorized into 2 times 3. So I see a 2. Okay, so I have a 2 common to both of them. I see a 3 that I'm going to need, but this one has an extra 2. So I need that extra 2. So I have 4 times 3, which is 12. Okay, so I would multiply this 4 by 3 to get the 12. So I need to multiply this 3 by 3. So 3 times 3. Plus 5. Now to get a 12 from a 6 would be times 2. So 5 times 2 would be the next thing. And then we would get 9 plus 10 over 12, which is 19 over 12. And those are our steps for adding. So let's take a look at this example to the right. Now I don't have numerical denominator. I have an algebraic expression. But I'm going to approach the problem in much the same way. I'm going to think, what is my common denominator? Well, I have x squared right here. So I have 2 x's. So I'm going to need 2 x's down here, x squared. Well, this side has a single x already. So since I already have taken care of that with the x squared, there is an x contained within there. I don't need another one. All right, so now I have a y, but this one has 3 of them. So y cubed. And now I'm going to think, well, what do I need to multiply this by to get this denominator? So x squared is taken care of, but y, see, I only have 1, but there's 3 in my denominator. So I would need to multiply by y squared. So I'll get 2y squared. Now plus, I think, what do I multiply this denominator by to get this denominator? And just an x. X times x is x squared, and I have the y cubed. So plus 5x. And there's nothing like up there, but I do want to put it in alphabetical order. And I cannot cancel these because we can never cancel through addition and subtraction. All right, I know it's hard to see, but right here we do have a 3 over x plus 1 plus 2 over x minus 3. So a trick that we're going to do is we're actually going to treat this all as one group. Okay, so this is a group right here. So now I'm going to think, all right, what's my common denominator? And you might think x, 1, and 3, but no, this is all one group. So the quantity x plus 1 and the quantity x minus 3 is my common denominator. So now I think, what do I multiply this fraction by? Well, what's missing in this denominator is the x minus 3. So x minus 3. Copy my plus 2. Now what's missing in this denominator is x plus 1. And now I have a little bit more work to do. I'm going to distribute in. So I'm going to get 3x minus 9 plus 2x plus 2 all over. Now I'm not actually going to distribute that new denominator. I actually want to leave it in factored form. And we'll just go ahead and simplify. 3x plus 2x is 5x. And then minus 5 all over x plus 1, x minus 3. Now, this is a correct answer, but we generally want to factor our numerator if possible. And I could factor out a 5. So I'd have 5 x minus 1 all over x plus 1, x minus 3. And the reason we want to do that is to see, does anything cancel? And nothing cancels. Now, I do have some restrictions. X cannot be -1, and x cannot be 3. And there's our final best answer, although this one right here is technically okay, but we do want to have, if possible, everything factored. Okay, it's not always going to be possible, and we'll see that a few times. Okay, so here are our steps. First, we're going to factor. Then we are going to get our common denominator. Then we are going to combine. And then we're going to simplify. And if possible, factor again. And finally, state any restrictions. That's what we need to do. Okay, so let's go through it. So we are going to factor. So we have 5. And we'll factor this. That's going to be x plus 4, x minus 1, plus 3 over, factor this, x minus 4, x plus 4. And now we need to identify our common denominator. Our common denominator, let's see, I have an x plus 4. So let's go ahead and write that, x plus 4. Okay, I also have an x plus 4 over here, but I already have written it. I don't need to write it twice. I've taken care of it. I just look at it and say, so I have the x plus 4 from this one. When I come over here to this fraction, I look in my denominator. Do I already have the x plus 4? And I do, so I don't need another one. We have an x minus 1. I know that's hard to see. And then an x minus 4. I should have chosen a better background. All right, so we have the 5. Now I ask myself, well, what do I need to multiply this by? What am I missing? Well, if I look at my denominator, this denominator has an x minus 4, and this one does not. So x minus 4 plus 3 times. And as I look in this denominator, I take a look, what's missing from down here? In an x minus 1. So x minus 1. Now we distribute, and we get 5x minus 20. And I'm really just going to work on this piece for now. I'll distribute right here, plus 3x minus 3. And that's going to give me, when I combine, 8x minus 23. I can't factor that. So now I'm going to copy down my denominator. I'm not going to bother multiplying that out. Okay. And I'm going to state my restrictions. X cannot be negative 4. X cannot be 1. And x cannot be 4. Okay. Hopefully you followed along with that. Let's go on. All right. So same steps, right? We're going to factor and get our common denominator, combine, and simplify. I do have a subtraction here, so I want to be aware of that. Let's factor out a 2 right here. So I'm just going to do a little bit of work on this. Now, we got to factor completely. Plus 3, plus 2. Okay, and this one's easy. X plus 5 and x plus 2. Okay, so our denominator, common denominator, there's no squared right here, is 2. See, I have a 2 right here. I have an x plus 3, all right, x plus 3. So got that one. I have an x plus 2. And x plus 5. X plus 2, but I already have the x plus 2, so that one's taken care of. So now I look at my numerator, so 3x, and I look at its denominator. Here's its denominator. And I look at this denominator and think, what's missing? The x plus 5. So x plus 5 minus 7x. I look at this denominator. What's missing? The x plus 3. So x plus 3. Okay, we distribute, so 3x squared, and I'm just going to work on this numerator a little bit. Plus 15x. Now, when I distribute this negative, it's going to go with it. So minus 7x squared minus 21x. I'm going to combine like terms. I get negative 4x squared minus, looks like 6x. Now, I can factor that. And I'm going to factor out a negative 2x. And I get x plus 3. So notice what's going to happen here. This shows why we do that extra step of factoring at the end. Is because now we can actually cancel some other things. I can cancel this x plus 3 right here. And I can cancel this 2 right here. And that's going to leave me with a final answer of negative x all over x plus 2, x plus 5. So that step of factoring that numerator at the end, if possible, is something you definitely need to do because something might cancel to make this simpler. And our restrictions, negative 2 and negative 5. X can't be those two things. Remember, the denominator cannot be 0. All right, let's go on. We're going to factor. We want to be very careful of that negative right there. So we're going to have x plus 3 all over x minus 5, x plus 4. The order that you write that in really doesn't matter. Very careful with that negative because it's going to have to distribute. Okay, so now we think, what's our common denominator? I'm going to switch colors so that it looks a little bit better down here. We have an x minus 5. All right, x minus 5. Good. We have an x plus 4. So x plus 4. Have an x plus 7. X plus 7. And an x plus 4, but I already have it, so I don't need it again. Okay, so in our numerator, x plus 3. Now notice I put that in a group, right? And I look at this denominator. What am I missing? Well, I'm missing the x plus 7. So what I'm actually doing is I'm taking x plus 7 and I'm multiplying it times top and bottom. But this has to be in parentheses right there because we are going to distribute. Don't be a lazy butt. All right, so we have a minus right here. And again, don't be a lazy butt. This is x minus 8 in parentheses. Write those parentheses because that's an important piece. So what are we missing in this denominator? The x minus 5. So we're actually going to multiply top and bottom by that x minus 5. Okay, so now I'm going to work on this numerator a little bit. And when I work on the numerator, I'm going to get, when I multiply out this piece right here, I'm going to get x squared plus 10x plus 21. Now I'm going to watch out for this minus for the next part. Minus. I'll multiply all this out, but it is going to be a minus, so watch what happens. I multiply it all out. But this minus needs to apply to all of these. So I would get x squared plus 10x plus 21 minus x squared. Now, if you don't write the parentheses, this is the only one you'll have negative, switch signs, but they all actually need to switch signs. We'll continue combining. The x squareds go away. And we get 23x and then minus 19. Okay, and that doesn't factor. All right, so at the bottom, we'll have 23x minus 19. What's our denominator? X minus 5, x plus 4. So nothing factored in that numerator, and nor does anything cancel. So our restrictions, x is not 5, x cannot be negative 4, and x cannot be negative 7. All right, one more example. Okay, now this one's pretty tricky. Whenever you have something like weird out of order like this, and then you have a negative right here, it should flag you that someone's trying to trick you, right? And at face value, we would think, oh, well, our common denominator is this. But actually, it's not. And the reason it's not is because we could apply this negative down into our denominator and switch this to an addition problem. And if we do that, we get negative 3 plus an x. And hopefully you're about to make the connection here. If we change this order, Well, now we already have a common denominator. And since we already have a common denominator, this problem just got a lot easier. Got a lot easier because we can do x plus 4 over x minus 3 plus x plus 2 over x minus 3. Common denominator is x minus 3. This denominator already has it, so it's x plus 4, x plus 2. Don't need to multiply by anything, and we get 2x plus 6 all over x minus 3. Now, if we can factor that, we can't do. And boy, we were actually really close to being able to cancel these, but just off by a little bit. Okay, that wraps up this section. Remember, factor, get a common denominator, combine, simplify, refactor if possible, and then cancel to reduce your fractions.